Hi everyone, this is the part 3 for reviewing for test 1. We have a graph of function here. This is a function because if you sketch some vertical line, the intersection between the vertical line and graph is at most 1 point. Okay, what we know about this function? I want to see what is the domain for this function. Domain is the set of all x values. We need to look at the graph of function. The function this way goes to negative infinity. It means that it contains all these x values. And here it goes to negative infinity. So y value, it's negative infinity, but the x value is positive infinity. And you see that it's continuous. So domain, it's all real number from negative infinity to positive infinity. Then, what is the range for this function? The range for the function, it's set of or collection of all y values. Because the function goes to negative infinity, so definitely it contains negative infinity. And it has all y values till here, which is positive 10. The greatest y value is positive 10. So from negative infinity to positive 10. And 10 is included because we have point negative 5 and 10 and positive 5 and 10 on the graph of function. By looking at the graph of function, you see that it is symmetric respect to the y-axis. We have point 5 and 10, the same distance. There is another point, negative 5 and 10. Here I have the point 10 and 0, and the same distance from the y-axis is negative 10 and 0. And for any points in the first and fourth quadrant, there is another corresponding point in the second and third quadrant. So y-axis is the axis of symmetry, and this shows that the graph of this function, based on the graph of function, we know that this is an even function. What we know about the increasing and decreasing interval for the function? Okay, I don't care about the arrows that goes down this side. All the time when we are looking for increasing or decreasing interval, we move in the positive direction of x-axis. So we move toward the positive. In this direction, x is increasing because, for example, this point x is here, then this point is here, this point is here. X is increasing, right? So I move toward the positive x and check if y is increasing and the graph goes up or down. If the graph, like this part, goes up and up, it is increasing. And if the graph goes down while x is increasing, as you see, x is increasing, it's decreasing. So this part, the graph is increasing, this part is decreasing. And in this part, the graph of function is constant because y value here is 10, and then it's 10 till 5 and 10. So the graph of function is increasing in the interval from negative infinity to negative 5, and it's decreasing from 5 to positive infinity, and it's constant between negative 5 and positive 5. Why I include negative 5 and positive 5 in the interval? because the y value here is 10, here is 10, and in between is 10. So the function is constant in all these intervals. Okay, now let's find the x-intercept. X-intercept is the intersection of function with x-axis. When the question asks about x-intercept, it means where y is 0. Also, if it asks what are the zeros of function, zeros of function, also it's x-intercept. What are the roots for the function? Again, means x-intercept. What is the solution set, or what are the solution set for this function? All these means x-intercept. Okay, here we have two x-intercepts. Here we have just 5 sections, so each section should be 5. So here is point 10 and 0, and this is point -10 and 0. So we have two x-intercepts, -10 and 0 and 10 and 0. And also there is one y-intercept, and this one is point 0 and 10. So y-intercept happens at point 0 and 10. Is there any minimum value for this function? No, because the graph function goes to -infinity and it's decreasing all the time. Is there any maximum? I can say that all these points are maximum for the function because they have the greatest y value. Now consider this function. Based on the graph of this function, I know that domain, it's from the starting point to the end points because this is a continuous function. So domain of this function is from -10 to +10 if these 2 points are included. Domain, it's from -10 to +10 if these 2 points are included. What is the range of the function? The range is from the minimum y value to the maximum if the function is continuous, like this function is continuous. So from minimum to maximum y value, it's from -9 to +9. It's obvious that this function is not even and it's not odd because it's not symmetric respect to the y-axis. Also, it's not symmetric respect to the origin. What we know about x-intercept? There are 3 x-intercepts for the function: point -5 and 0, 1 and 0, 5 and 0. How about y-intercept? Y-intercept for the function is point 0 and 5. Okay, what we know about the function, it's increasing or decreasing. And what is the minimum and maximum point for the function? This function is not increasing and it's not decreasing overall. In some interval, it's decreasing, and in some interval, it's increasing. For example, in this interval, the function is decreasing because when x is increasing, you see the value of function goes down and down. And then it's increasing from here to here, again decreasing from here to here, increasing, decreasing, and increasing. So what are the absolute minimum, local minimum, absolute maximum, and local maximum for this function? To find the minimum, look at the behavior of the function. At the minimum point, no matter it's absolute or local, the behavior of function is decreasing, then increasing. Decreasing, then increasing. So here we have a minimum because the function is decreasing and then increasing. It goes up. Here again, the function, you see that before 1 and 0 is decreasing, it goes down, and then it goes up. Another minimum point is this, because before 5 and 0, the function is decreasing, and then it's increasing. So which one is local and which one is absolute? All these points are local minimum because they are minimum point for some section of the domain. But the lowest y value is the absolute minimum. So among all between 0, 0, and -9, definitely -9 is the smallest y value. So the point -8 and -9, it's the absolute minimum. And also it's local minimum as well. 1 and 0 is local minimum and 5 and 0 is local minimum. The behavior of function around the maximum is opposite. The function is increasing before maximum and after maximum is decreasing. Increasing before and after decreasing, and here is the maximum. Here you see that there are 2 points with this property. The function is increasing, then decreasing. It's increasing and then it's decreasing. So both 3 and 4, -2 and 9, are local maximum. And the greatest y value, which is +9, point -29, is the absolute maximum for this function.